the structure of the human eye. This upper part in the form of convex. So this is in the form of convex. The upper part is cornea and iris, pupil, aqueous humor, eye lens, suspensory ligament, ciliary muscles, retina, blind spot, optic nerve, vitreous humor. So I have introduced all these things in the last class. So this is cornea. What happens? Light from some object enters the eye through this cornea. So here is this convex part. So some of the light is refracted from this convex part. After that, the light goes to this pupil, and from this pupil, the intensity of the light is controlled. Okay, but the control of the pupil is in the hand of iris. Iris controls the pupil, so intensity of the light indirectly we can say is controlled by iris. So now basically we have the light here, and this light enters strike, you can say, on eye lens, and eye lens is a convex lens, and this convex lens converges the light or produces the image of the object on retina. Retina is like a screen, like the screen of your laptop. You are getting my image, you are getting the image of this eye. Okay, so iris and pupil, you can see here this thing na, this part is iris and this part is pupil. So the contraction of iris and iris will reduce the size of the pupil. You can say the iris control the size of the pupil, okay, or indirectly. So light goes to the eye through this pupil. So the size of the pupil is controlled by the iris. Okay, so you can say the intensity of the light is controlled by the iris. Okay, by adjusting the size of the pupil. And basic things we have completed also in human eye. Have we written all the definitions?
Yes, sir.
We have written na all the definitions, like I have told you what is pupil, what is eye lens, what is ciliary muscles, what is retina. Told you na? Arshia?
Yes, sir, we did.
We did na? Okay. So today we will discuss first the working of the human eye. Okay. So I will write this, what is the working of the human eye. Okay. So basically you know what is happening. See the working of my eye, how my eye is working basically. How I know this is a black color pen, and how I know this is something mobile phone, and there is something on the screen also. Okay, you can see here. So how I got to know? Actually, what is happening? This is the object for my eye. Theory we can see from books and all that, but just we can feel here what is happening. This is our phone. This is my phone, and this screen is visible to me. This screen is visible to me, and how this screen is visible to me. Okay, so basically what is happening here? This is my eye. Okay, and here is iris and pupil also in my eye, because we are talking about the human eye and I am also human. So okay, so this is the object. This mobile phone for my eye is the object. Okay, I have told you object is a source of light. So light is coming from this mobile phone to my eye. And now how you will say how the light can come from this mobile phone? Here is one light. Okay, due to the reflection, light is striking on this phone, and from this phone the light is entering in my eye. So basically this phone is giving out the light. Okay, some of the light is going into my eye, and the upper part of my eye is cornea. So you can say that the light entering my eye through the, and this thing na, this thing is known as the eyelid. This is shutter type thing. If I will close this, then no light is entering. Now light is entering. Okay, so this thing should be clear. So basically light first enters through the cornea. So cornea is basically convex type from outside, bulging outward or convex. So from that some of the light will be converged or refracted, you can say. And after that the light enters, light of this phone means how I am able to see this phone. Okay, so through cornea light goes to the pupil, and through pupil light falls on the eye lens. There is one eye lens also in our eye, that is convex lens, natural convex lens. That lens is known as the natural convex lens. So we know that if there is a lens and in front of the lens an object is placed, there will be the image. There will be the image now. That is why we have studied the image formation by convex lens. So there will be the image, and where that image will be formed? On retina for normal eye. For normal eye. For normal eye, the image will be formed on retina, and retina have the light sensitive cells. So when the image formed on the retina, those light sensitive cells known as rods and cones, okay, gets activated, and through the optic nerve these light sensitive cells convert the image into the electrical signal, and those signals are sent to our brain through the optic nerve, and through the optic nerve. And now rest of the things is done by our brain. Our brain interpreted the image. One question I want to ask you from Martin. We have two eyes. Okay, we have two eyes. Okay, just wait. And this is one mobile phone. So if we have two eyes, then we should have two. We must suppose, take my example. I have two eyes. Okay. Hello, Subhana. I have two eyes, and if I have two eyes, so I can say I have two convex lens, one here and one here, one in eye, one in this eye, and one in this eye. Two convex lens. So there will be two images. There will be two images, but I am only able to see this one image of this phone. How?
Just focusing on like one,
Hmm?
focusing on one. Oh,
And one more thing. The image formed by the convex lens of this object. Actually, what is happening? If I am saying that this pen is like this in actual. So on retina, the image of this pen will be inverted image. But then also we are getting the image, erect image. Actually, this is due to the functioning of the brain. This is due to the functioning of the brain. Okay, brain interpreted the real or inverted image into the erect image, and basically two images are there. We got two images. We should have two images because we have two eyes. So our brain has a functioning like that, so that converts two images into a single image. So that is why we are able to get one single image only. Otherwise, if someone has defect, he or she can get two images of this mobile phone also. Okay, got it now, all of you?
yes.
Yes, sir.
Hello, Subhana. Okay, so we will write here working of now. I will only write with me, all of you. I have already explained you what is happening in your eye and how you are getting the image. And Afra, you are new here, so uh, if you are not getting the actually this thing is related with the previous things. Okay, so you should know the basic structures of the human eye for the work for understanding of the working of human eye. So if you are not getting, then you can just stay in the class and try to get the things. Okay, and you should go for the video lecture. Hamna, hello. Hamna, you why you are late today? Okay. So I am writing. Write with me. The light coming from object. I have already explained you, so you can write with me also. The light coming from the object in front of us enters through the cornea. Enters through cornea in our eye. You can write here outer surface of cornea is convex. So most of light, so most of the light converges by cornea. Okay. So after the light converges by the cornea, okay, upper part or the outer part of the cornea, light enters into the pupil. Okay, so you can write then light passes through pupil and fall on eye lens. So now the light is falling on the eye lens. Eye lens is a convex lens. So eye lens will what will do? What eye lens will do? Eye lens will converge the light rays, and due to that convergence, the image will form on retina. So on eye lens, so you can write here the final convergence of light is done by eye lens. to form the image of object on retina. You should know what is retina. Retina is like a screen in your eye. Now till here image has formed on retina. Now see what happens. Retina have light sensitive cells. Light sensitive cells, that is rods and cones. They are rods and cones because the shape of these cells are like rod means like this type of thing, a cylinder thing. Cone means a cone. Rods and cone. So you can write here when image forms on retina, these cells get activated and generate electrical signals. These electrical signals are sent to brain by optic nerve and gives rise to the sensation of vision. One more point here. Although image formed on retina is inverted, but our mind interpret interprets the image as that of erect object. So this is the working of the theory part of working of human eye. You can write this thing in your language also. Okay, note down this. Hamna, are you writing? Yes. Hamna, hello. Subhana. Archia, are you writing?
Yes, sir.
Martin,
Yeah, yes.
Abdullah,
Yes, sir. Yes, sir.
Subhana, is your mic working or not? You can use chat box. Subhana, are you writing? Okay. Martin completed.
Yes, sir.
Arshia,
No, sir. One, sir.
okay, no problem. Hamna,
Completed.
Hamna completed.
No, sir. I completed.
I know that you completed. I am asking from Hamna.
Okay, sir.
Beta, if you will not tell me, then how will I know that have you completed or not? Okay. Hamna and Subhana. You can just write Y means yes in the chat box. Okay. Or you can write D for done in the chat box if you have completed. Okay. Then I will move forward. Okay. Now this is the basic of the human eye. Now we will discuss the power of accommodation. You have seen the focus mode in your phone. There is a focus mode. in our phone, but our eye has the ability to focus the object which are far from us and which are near from us. So suppose I want to focus on this pen, suppose I want to focus on this increase, so on this screen, so I can do that. Okay, so this is what the power of accommodation we will see here. So before the power of accommodation, you should know a certain number of things. So distant object, what? Distant object. So what is this distant object? So basically distance object means object which is far from you. An object which is far from, how much far? Very much far. Okay, very large distance. Suppose you are watching the mountains from the top of your building. So that mountain will be the distant object. So basically from the distant object means you can say far object. Light rays comes parallelly. So that distant object will give you the parallel light rays. So here I have written written the light rays coming from the distant object are parallel. This thing you should know. Now nearby object. Nearby object like this pen for me is the nearby object for me. So from the nearby object you will get the diverging light rays, because see here this pen will give the light in all the possible direction. So that is why I will get the diverge form of light rays. So this is your object. This is your object O, and this object is giving the light rays. Okay, and these light rays are diverged light rays. So light rays coming from a nearby object are diverging. 2 point you should know. Now what is the power of accommodation? What is the power of accommodation? The ability, power of accommodation means the ability of an eye to focus the distant object. We know what is distant object, object which are far from us, distant object, and as well as the nearby object on retina by changing the focal length, or the converging power of the its length is called accommodation, or you can say power of accommodation. So I have told you the ciliary muscles in our eye is able to change the shape of the lens, and due to the change of the shape of the lens, the focal length of the power can be changed, and due to the change in the focal length of the power of the focal length of the lens, the power of the lens can be changed, because power is equal to 1 by focal length. Okay, so if you will change this focal length, your power will change. If you will increase focal length, power will decrease. If you will decrease focal length, then power will increase. So this is the power of accommodation. Power of accommodation. So see the mechanism, how we see the far objects and how we see the nearby object. So here is one object which is far. Here is these light rays. This is our eye. This is our eye, and somewhere here, a object which is far from this eye, and I have told you light rays from the far object are parallel. So light rays are parallel these light rays are coming from the far object. Okay, so see, these light rays are coming from the far object like this, and entering the eye through the cornea, and after that entering the pupil, and after that striking on the eye lens, and this eye lens is a convex lens, so this will converge the light rays, and finally we will get the image on retina. Okay, on retina we will get the image. So this is your eye lens, and these are the ciliary muscles. Okay, these are the ligaments. And one thing here means, in this condition, when the object is far, the ciliary muscles are relaxed. Okay, relaxed means uh, light is coming from the far object, so light is coming parallel light is coming. So the power of the lens required for converging the lens should be small. Okay, a small power of the lens can handle these light rays, and we can see the object clearly. Okay, so remember one thing: if your eye lens is thin, this thing you should know. If your lens becomes thin, then you can say your focal length, small f means focal length, is large. If your focal length is large, then you can say your power is small, converging power, or you can say diverging power. Power is small. So basically, when the object is far, so the eye lens will be thin in that case. Okay, so eye lens will be thin, and the focal length in that case will be large, so the converging power of this lens will be small. Okay, and after that, due to the small converging power, as the rays are parallel from some object, so this lens should have the small converging power. Okay, only small converging power is required to converge the parallel light rays. But when the light rays becomes in the form of diverge, when the diverged light rays are there, okay, suppose you have a lens and these rays are in the form of diverge rays, so a lens of large power is required to converge. Okay, here, okay, due to the action of the ciliary muscles, this lens is thin and power is converging power is small, and we are getting the image here. So that's how we see the distant object. Okay, okay, so here is a object and this object is nearby, like this pen. For me, this pen for me is a nearby object. So what happens? I have told you the nearby object gives the diverging rays, and for converging the diverging rays, power of the lens required will be more. Power of the lens required will be more means the focal length should be small. So focal length should be small. So when the object in front of the normal eye is nearby, okay, so you can see this eye lens becomes thick. So that the focal length should be reduced and the power should be increased. And how the focal length will be adjusted? By this ciliary muscles. So the ciliary muscles contracted, and due to the contraction of these ciliary muscles, the eye lens becomes thick. Eye lens become thick, and focal length decreases. Okay, focal length decreases and power increases. Converging power increases, because converging power is equal to 1 upon focal length. When focal length will increase, power will decrease. When focal length will decrease, power will increase. Okay, so these are the diverging rays. So now, and finally we will get the image on the retina. So when the object is far from us, okay, the lens is thin. Okay, the lens becomes thin due to the action of ciliary muscles, and you can say in a relaxed condition. The lens is in a relaxed condition, or ciliary muscles in a is in a relaxed condition, because less power is required to converge the light rays from the distant object. But when the object is nearby, okay, when the object is nearby, the power required to converge the diverging rays from the nearby object is large. Okay, so power is large, so ciliary muscles will be contracted. Okay, when the ciliary muscles is contracted, eye lens become thick. Okay, and when the eye lens become thick, focal length decreases. Okay, so you can write here, when your lens is thick, so you can say focal length will decrease. So if your focal length decrease, then from this formula you can say your power will increase. Power of the lens will increase. Okay, note down this. All of you note down. Arfa, are you getting?
Yes, sir.
Hmm?
Yes, sir.
Okay, good, good. Note down, all of you. So that is how our eye is able to focus on different object at different places, at different distances. When the object is far, okay, so less power is required by the eye lens for the converging of the light rays. When the object is near, more power is required by the eye lens for the convergence of the light rays from nearby object. Basically, this is the thing. Done?
Yes, sir. Complete.
Martin?
Yeah, done, sir.
So this is the action of the eyes when the object is far from us. Okay, so you can draw this diagram also. And here this P is power. P is the power, and F is focal length. Don't compare this power with that 9th class power. Rate of doing work, that is a different power. This is known as optical power or converging or diverging power. So I am writing here what is P, power of lens. Okay, what is F? I should write here focal length. So these are the light rays coming from a far object, parallel light rays, okay, entering the eye, and this is the lens, and from this lens these light rays are getting converged, and due to the convergence image is formed on retina, and we are able to see the object which is at a some distance, and or you can say a far distance. Okay, so in this case less power is required for converging the light rays. Done, all of you? Martin,
Yeah,
Arshia,
done, sir.
Hamna, Subhana, and Afra. Afra, are you writing?
Yes.
Completed? Have you completed this?
Yeah. Sir, I
Completed. Hamna, completed. Martin,
Yeah, completed, sir.
very good. Subhana. Hamna, if you have completed, you can write in the chat box. Okay, very good. Okay, now we will see the phenomena I have already told you when the object is nearby, like this pen is nearby for my eye. So what will happen? Less, I mean, more power of convergence of lens is required. Okay, simply. So draw this diagram again. This is the nearby object, and I have told you now from the nearby object the light rays will be in the form of converging light rays. So these are the light rays converging, diverging light rays. Sorry, not converging. From the nearby object, light rays are converging, and for the light rays are diverging. This is the nearby object, and due to this nearby object, the light rays are diverging, and to convert the diverging light rays, to converge these diverging light rays by this lens power should be more. And how the power of lens should be more? By reducing the focal length. And how the focal length of the lens will be reduced? By the action of the ciliary muscle. Ciliary muscle will make this lens thick so that the focal length will be reduced. Focal length reduced, power will increase. Okay, now note down this also. So here the ciliary muscles will be contracted to reduce the focal length or to make the lens thick. So here the ligaments are loose. Okay, ligaments are loose so that the lens become thick. If the ligaments will be stretched, then lens become thin. Okay, focal length will increase at that time. Okay, all of you note down this, and we will meet in the next class now. After that, and in the next class, we will discuss the defects of vision. Defects of vision we will discuss in the next class. So don't miss the next class because each class is linked with the another class. Okay, Martin?
Okay, sir.
And be on time in the class, all of you. So Afra, have you got this? How our eye works?
Yes, sir.
Okay. If you have any doubt, then you can ask me. So if anyone have doubt, Hamna, Martin, Subhana, Afra, then you can ask me.